In section 6 of module 4, in your textbook, you do see the summary of sets of numbers. Up to now, we've only been talking about real numbers, and we're introduced in this section to imaginary numbers. This is just a term they give them. They're not imaginary. And collectively, they are under the umbrella of complex numbers. So this raises us to a new category with a big umbrella of numbers. Most of the things we'll deal with are real numbers, but we now have imaginary. There's complex imaginary and pure imaginary, and of course all these others, rational, irrational under real. And the big new topic is complex numbers, where we introduce the letter I as the square root of -1. All right, let's take a look at some of the others now. And as we look at the exercise set for section 6 of module 4, we're asked to do some true-false. See if we can make it a little bigger here. And we will give assignments. And we'll do up to number 14. So let's pause, get our assignment for true-false. Let's see, there's 1, 2, 3, 4. So here it's 4 true and 4 false. And then we have these numbers to work with down there. Okay, lots of stuff here. Let's start with number 1. Imaginary numbers are so named because they have no real world application. No, they do have real world applications, and so that's not true. Every real number is imaginary. See, this part right here is false. No real number is imaginary. All right, let's go on to number 3. Every imaginary number is a complex number. That part is true. But not every complex number is imaginary. And that part is true also. We can look at it here. Here, this is imaginary. This is real. Remember, the formula for complex number is A plus BI, where A is the real number and BI is the imaginary. Together, this is the complex number. All right, letter or number 5. We multiply complex numbers by multiplying real parts and multiplying imaginary parts. When we FOIL this would be imaginary, but when we do our outers, this is a real by an imaginary. So that's why that is false. Number 6, the product of a complex number and its conjugate is always a real number. And we see that down here when we multiply this by its conjugate. And I should have that the other way, but we could do it this way too. So these are the conjugates. When we do that, since the middle terms that would have been imaginary over here end up as being I squared, which we know is a -1. Number 7, the square of a complex number is always a real number. Well, here, this is the square of a complex number, and it is not a real number when you end up, because the middle term is still imaginary. This I squared, we know, becomes a -1. The quotient of two complex numbers is always a complex number. So even though we rationalize, in a sense, or make it a real number, our denominator, by multiplying it by its conjugate, and of course the numerator by its conjugate, well, the numerator by 1, which is the conjugate of our denominator. That's better. Here, this is not going to end up as being a real number. It's still going to be a complex number. Okay, and then now for our examples that we're working out. Again, you take out a square root of -1, which is I, and then the square root of 10. 100 is 10. And the same thing here. Here, since this is not a perfect square, you just take out the square root of -1, which is I. And the same thing here. Now, I left these sort of undone in that when you have the square root of -8, you take out the square root of -1, which is I. The square root of 4 is 2. And then what's left is the square root of 2. So this would be written usually 2I, the square root of 2. We usually put the letter after the number. And the same thing here. This is I. This is going to be 2, the square root of 3, and this would be written 2I, the square root of 3. Now, if you can remember this, the square root of -8 is always 2I, the square root of 2, and the square root of -12 is 2I, the square root of 3. And this is how we get there. Okay, you'll be doing your practice, and hopefully shortly you'll be doing your modular test on Module 4.